This is a review video for a chapter in Algebra 1 that is about inequalities. So the book that I am working from, this is chapter 6, but it could be located somewhere else. It's all about linear inequalities. It starts off very basic here. If we look at number 1 and number 2, all we're asked to do is to draw a graph of the inequality. So the things that are important here is that if it is equal to or not equal to. So 1 is not equal to because it doesn't have a line underneath the inequality, whereas 2 does have a line underneath the inequality, so 2 is equal to. So if it's not equal to as an inequality, when we put that on a number line, that gives us a non-filled in circle, so just like a regular circle. But if it is equal to, then we're going to draw a dot that is filled in on our number line. So b is greater than 1, we're going to put an open circle at 1. And then we're going to shade the direction of the numbers that are bigger than 1. So if you think about that, that's numbers like 2, 3, 4, 5, 6, 7. So we're going to shade to the right. Another way that you can tell which way to shade is by pretending that this is an arrow and saying which way does the arrow point. That only works if your variable is on the left side. So b is on the left, so we can use that trick. If b wasn't on the left, if it was on the right side, then we would have to move it around, and that'll happen later on in the video, so you'll see what I mean. On number 2, it's equal to, so we'll put a filled in circle at -6. We want to shade all the numbers that are less than or equal to -6, which is numbers to the left, or we can look at the inequality and say, that looks like an arrow pointing to the left. So if you notice the way I'm shading, it helps that I am using red, and I'm using, mainly the fact that I'm using red and it's coloring over where you can see it. Make sure when you shade on a number line that it's easy to tell which way you shaded, that it's easy to tell whether it's filled in or not. A trick that some people will do is they'll actually go up, and some teachers really like that. Make sure you know what your teacher wants you to do. I personally just want it to be obvious what you're doing, which way you're going and things like that. Doesn't matter to me otherwise. On 3 through 6 here, we're going to solve the inequality and graph its solution. So the part with solving means that we should get an answer that is another inequality, but the inequality should be solved for our variable. Just like when we solve an equation, we solve for x or whatever our letter is. So on 3, to get r by itself, just like in an equation, we're going to subtract 9 from both sides. 8 minus 9 is -1. We're going to keep it as greater than. We want to keep track of that inequality. There's only 2 reasons to change the inequality. And if it's greater than and it doesn't have an equal to symbol, there's not anything that we could ever do that would cause this to all of a sudden switch to an equal to. So make sure you're paying attention to your inequality as you go along. But if we want to graph this, we actually want to move this, flip this around so that the variable is on the left, so we can use our trick for graphing. So if I put r on the left and I put -1 on the right, what I have to do is flip the inequality so that it's going the other way. It was greater than, so now it's going to be less than. So the numbers I want to shade are starting at -1 with an open circle, and then I want to shade to the left, because I want to shade all the numbers that are less than -1. So it may be that you can take this and shade it the correct direction by saying, if -1 is bigger than r and I want to shade r, which way does that mean? But a lot of us would rather just use that trick where we look at the inequality for the direction to shade, but you have to have the variable on the left side in order to do that. On number 4, we need to solve this for x, so we're going to divide both sides by -7. And if you are reviewing right now and not learning for the first time, you'll remember that when we divide by a negative for an inequality, it flips the symbol around. So it's the only other time that our inequality will change, either because we're changing what side our variable is on, like we did on 3, or in this case, if we multiply or divide by a negative number, it flips it so it's the other way. So it's the fact that I divided by a -7 that does that. It doesn't matter that the 70 is negative. It just so happens that it is. What matters is I divided by -7. So this is a filled in circle at 10. Our variable is on the correct side, so we're going to shade to the right. We want the numbers that are bigger than 10. On 5 and 6, there's a couple more steps to this process. Like on 5, just like in an equation where we have something right next to our variable and then something added or subtracted, we have to take care of what's out here being added or subtracted first before we do the division. So it's like opposite of the order of operations we use when there's not a variable around for an equation. So we're going to subtract 5, which gives us -3m is greater than or equal to 18. And then we'll divide by -3. And because we divided by a negative, we're going to flip the inequality around. And we get m is less than or equal to -6. So at -6, I'll put a filled in circle. Then I'm going to shade to the right. I mean the left. That's totally the direction I'm going. The left. Number 6, there's actually 2 ways that you could do this. One is we can actually divide by that -5 on both sides to start off. The other way is to distribute. I feel like more of us would probably think to distribute by -5 to start off. You should still come up with the right answer if you do it all correctly in between. Make sure when you distribute here, -5 times -1 is 5. -5 times a is -5a. Lots of people will even draw the arrows up here, and yet they will forget to actually like multiply the second thing by -5. Now, we don't have to change the inequality because we didn't do anything yet. Like, we're just simplifying what was already done. Or another way to look at it is we didn't do it to both sides, that -5. So there's no need to flip the inequality yet. But we do need to subtract this 5 from both sides and have -5a is less than 10. And then divide by -5 and have a is greater than -2. So we put an open dot at -2 and then draw to the right. So this is kind of the first couple sections that you would find in an Algebra 1 book with that in a section or a chapter about inequalities. From here, like that's really actually typically review from pre-algebra. So from here we'll get into stuff that might be a little bit more new, like compound inequalities. So a compound inequality is an inequality that has 2 different inequalities at the same time. These inequalities are either and or. And inequalities you shade between the 2 numbers you get, or you shade outside the 2 numbers you get. One way you can remember this is or has an O and outside has an O. When we have an and, there's 2 ways that can look. 7 and 9 are both ands. 9, that should be obvious because it says and. And it should be obvious that 8 and 10 are ors because they say or. So the question is, why is 7 considered an and? Besides the fact that I just told you it's an and. Well, what's happening is that x right here is in between 2 numbers. And so once we solve, it'll still be in between 2 numbers. And if x is in between these 2 numbers, then it has to be something in the middle, which is the very definition of us shading between those two numbers. So to solve this, we want to look at the middle here and say, how do I get x by itself? Well, and when I divide by -2, because there's actually 3 parts to this inequality, I'm going to divide all 3 things by -2, like so. So -18 divided by -2 is 9. I divided by -2, so this is actually going to flip both of our inequalities. -16 divided by -2 is 8. What this is telling us is that x is between 8 and 9. It's saying, if I read this, it's saying 9 is bigger than x, and x is bigger than 8. Well, if you are stuck in a before algebra kind of mindset, you might be thinking, well, there's not actually anything in between 9 and 8. But don't forget all those decimal numbers. There's infinitely many numbers in between 8 and 9, like 8.5 or 8.4362789. So we're saying the only answers that work for this are between 8 and 9. Now, this is how we came up. This is like our answer when we solved. But actually, the better way to put this, like normally when we have it written this way, we actually will put the smaller number first, or the more negative number first. To do that, we'd flip the inequalities around again if we just write it in the opposite order. So technically the second way is the better way of putting that, but depending on your teacher, they might accept it either way, like I will accept it either way in Algebra 1. On 8, it says or. So these are two completely separate inequalities here, separated by this or. So we're going to take 10x greater than 90 and solve that by dividing by 10. So we get x is greater than 9. And then we're going to look at x minus 6 is less than or equal to -8. So that's going to add 6 to both sides. So x is less than or equal to -2. So one of the things with this is, by the way, is we're solving the inequality. So this is the answer to our inequality, like that's our solution. And then we're being asked to graph that solution. So it's like our answer really has 2 parts. This inequality that I have, set of inequalities that I've circled, but also the part where I graph it. So I'm going to put an open circle at 9 because it's not equal to 9. I'm going to put a filled in circle at -2. And then as far as shading goes, since it's an or, we know that we should shade out. But also the inequalities tell us if we shade bigger than 9, that's to the right of 9. And then if we shade less than or equal to -2, that's so whether we can say, oh, it's an or, so it's out, or whether we look at the inequalities, either way, we should be able to come up with which way to shade. Number 9, we just need to solve this. It says and, so we'll do that. We'll do -8 on the first one and get x is less than or equal to -3. We'll add 6 to both sides on the second one and have x is greater than -9. So x is less than or equal to -3 and x is greater than -9. So that means that we're shading between -3 and -9. -9 is an open circle, -3 is a filled in circle. Shade between. Now we could write the answer on 9 combined like what it was. Is to take the number on the left, put a less than symbol, x less than, and then put the number on the right. So we're saying that because when you think of this, you're actually saying x is bigger than -9 because it's like you're reading the inequality backwards. X is bigger than -9. X is smaller than -3. That's how I think of it personally. But either way, you can leave them separate, you can put them together. What we can't do is you can't, this is or as in both of these answers work. You can't combine an or. So like on this problem, I would not want to put -2 is less than or equal to x is less than 9, because this implies that I'm shading between, and I'm not. So that's wrong. Don't do that. Don't ever do that. On 10, this is an or, so we should shade out. We're going to do -7. M is less than or equal to 6, or divide by -3 on the second one. M is greater than or equal to 7. So we're saying less than or equal to 6, greater than or equal to 7. This is kind of the opposite of what happened to us on number 7, because they're really close together, and then we're shading out instead of between. So again, if we're ignoring decimals, this seems like a really uninteresting sort of thing, because there aren't any numbers in between 6 and 7 except for decimals. But I mean, there's a lot of decimals in between. A whole lot.
11 and 12 are similar to what we did on the previous problems. They're just a little bit more complicated on the solving part. So on 11, we have an or, which means that our graph is going to shade out from one another. 12 is another and. We know it's an and because they didn't write a word. If they don't write a word, it has to be an and. And also because that's what's happening whenever we end up solving it. We're going to have x in the middle, and we'll have numbers on either side showing that our answer should be between those numbers. So starting on 11, we want to solve 5b minus 10 is greater than 20. And then we also want to solve 7 plus 4b is less than or equal to -21. So I'm going to add 10 to both sides, so that I get 5b is greater than 30, and then I would divide both sides by 5, so b is greater than 6. And then I'm going to subtract 7. -21 minus 7 makes a more negative number of -28, and then I'm going to divide both sides by 4, so that b is less than or equal to -24. JK, I didn't divide, I tried to subtract. -28 divided by 4 is -7. So these are supposed to point away from each other. So -7, which is right here in between -6 and -8, is a filled in circle and shades to the left, which I can tell based on the way the inequality is pointing. At 6, we're an open circle, and we should shade to the right. And so we can verify that, yes, these did shade apart. So we're good to go. On 12, when it's written as one long inequality like this, we're trying to solve the middle for x. So think of it like if you knew what it equaled, that we would subtract the 5 first and then divide by 2. We always divide last. We're going to do the same process. I'm going to subtract 5 on the left, I'm going to subtract it in the middle, and I'm going to subtract it on the right. When we're adding or subtracting in an equation or inequality, we only do that once for each part that we have. So I didn't subtract 5 from 2x also. I'm just subtracting 5 from the middle. And so that's different from whenever I divide everything. So even if there was something else in the middle, I would also have to divide it as well. So we get 6 is less than or equal to x is less than or equal to 9. And so you may think, oh, those are both pointing to the left, but remember that this is not in the right order for us to actually use that trick of which way it's pointing. And so really it's saying that x is between 6 and 9. So I'm going to put filled in circles at 6 and at 9, and then I'm going to shade in between them. And that's my answer. And this is one way to write your answer. You also could split it up. You could say that x is greater than or equal to 6, so switching this around, and x is less than or equal to 9. But I'm fine with you leaving it this first way. It's up to you which way you want to write it. Now, if you are watching this because you're in my class and you're following through on the review, the rest of this video, the numbers do not match up with our review. So it does go in the correct order, though. That just makes it a little bit more difficult if you're skipping around. So just make sure that the problem actually matches up with what you are trying to do. I have complete confidence in your ability to be able to figure that out. So
the last thing that's typically in a section like this, maybe not the last, but usually around the last-ish, is graphing in two variables, which just makes things more fun. Since we have two variables, we have to use an XY axis instead of just a number line. We're going to graph like we did in an earlier chapter on graphing, where we look at the y-intercepts and the slope. The other thing we add to this is, instead of filled in circles and open circles, it's equal to, it's going to be a solid line like normal, but if it's not equal to, we're going to make it a dashed or dotted line. I personally prefer dashes, but you might prefer dots, and that's okay. Just so long as it's not solid, we're good. So, and then we'll talk about shading here in a sec. So we start at -5. We want to do a positive slope of 5 over 1. So I'm going to go up 5 and right 1, because that's, both of those are positive. I can do it again if I want to. I apologize in advance for how my line might look, because drawing on a computer screen is hard. I mean, it could be worse. So here's my trick to knowing which way to shade. Is if it says greater than or equal to means we want to shade above this line. The question is, where is above this line? Particularly because I drew a really, really bad looking line. So the trick is, you put your pencil anywhere on this graph, and since it's shade above, we're going to draw an arrow straight up. Whatever side of your line you just drew that on, that's where you're going to shade. So I'm going to shade this side of my line because that's the side that that arrow I just drew is on. So all of this gets shaded. All of this. Every single bit. A dashed line, I need to make sure that I'm aware of that before I get too carried away, especially if I'm using pen, which I shouldn't because this is math. The number in front of x is 1, so my slope is 1 over 1. The y-intercept is -1, so I'm going to put a dot here, then a dot here. I can put more dots, or I can just go for my dashed line. It should look like this. And then we're going to shade, since it's greater than, we're going to shade above again. So there are some later on that are below, but since I want to shade above, this line, to me, it's easier to tell which way is above, but we can still use our trick and say, well, if I go up, that's the side, so I'm going to shade all of this. Make sure that when you're shading that it's still obvious that your line is either solid or dashed. Like if you shade right up to the line really darkly, it might be hard for your teacher to tell, and that would be sad for them. 21. Hey, this one's less than or equal to. It's a solid line because it's equal to. We're going to start at 4, and our slope is negative, so we're going to go down 3 and right 1. Then to shade this below, instead of drawing an arrow up, we're going to draw an arrow down. So we're going to put our pencil somewhere on here and draw down. That's the side that is less than or equal to, so this side right here. Now, x and a y, it just has an x, so we have to remember from our earlier chapter on graphing lines that x is a vertical line because its slope, m, is undefined. So we need the kind of line where a skier would have an undefined amount of fun, which is up and down. So we're going to draw a dashed line vertically through -3. Now, I can't draw above or below this line, so I need to think about, since it's less than, where are the numbers for x that are less than -3, which are these numbers over here. These numbers are less than -3, so we're going to shade all of this. And again, like, see how if I get really close to my line, it's going to start making it hard to tell if that's dashed. Don't do that. That's not helpful. On 23 and 24 and 26 on the next slide, we need to solve for y so that we can graph. So I'm going to subtract 2x. Get y is less than -2x minus 2. And then graph like what we've been doing. So start at -2. My slope is down to right 1. If you're having a lot of problems with graphing, and I might have some videos on that. If I do, they would be chapter 3. Or you could look up, just Google graphing linear equations. It's less than, so less than for this line, draw an arrow down. That's this side right here. 24, we want to solve for y, and this is actually a really similar equation because we've got lots of 2's, but this time I have -y instead of +y, and believe it or not, that makes kind of a big difference because I don't want to leave it -y or accidentally forget that negative's there. I want to divide by -1, and that means that it flips the inequality and changes all of these signs. So if we don't remember to do that, we'll not get the answer right. That's over 1, so up 2 over 1. This is a solid line. We want to shade less than, which is below. This side. These are the last two I have. So y, we can still think of as slope-intercept form if we put a 0x, meaning that this has a slope of 0, so it goes through 3 is a horizontal. Or we can just remember that y without x is a horizontal line. So dashed line at 3. If I want less than, and it's a horizontal line, I can use above or below. So that's below. If it was greater than, we'd shade above. On 26, we want to subtract x from both sides. And get -2y is greater than -x minus 10. Divide both sides by -2. When we do that, two things need to happen. We need to flip our inequality because we divided by a negative. Then we have to do both of these. So this is like a -1 over a -2, which is a +1/2 x. -10 over -2 is a +5. We're going to put a dot at 5, go up 1 over 2. And dash, because it's not equal to. And then it says less than, so we're below. And that's pretty typically what is covered in an Algebra 1 text when we're talking about linear inequalities. So happy studying.